With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. So today we are going to discuss one question on circles. So here in this question we are given the following figure, and in this figure we need to find the angle BCD and the angle BFE. But before that we are given the measure of the angle BAD as 96 degrees. And in the second part of the question we need to prove that the AD is parallel to FE. So let us visualize this question by using this given diagram. So in this question we are given this angle BAD as 96 degrees as shown here, and we need to find this angle, that is the angle BCD. So we need to find this angle, and we also need to find the angle BFE. So the angle BFE is this. So we need to find these two angles. Now here we can see that the point AB, C and D, all of these 4 points lie on this circle. So we can conclude that the quadrilateral ABCD is a cyclic quadrilateral. So here we have the quadrilateral ABCD as cyclic quadrilateral. Now since this is a cyclic quadrilateral, so we know that in a cyclic quadrilateral the sum of opposite angles is 180 degrees. That is, the opposite angles are supplementary to each other. So here we can say that the angle BAD and the angle BCD, both of these angles, if we sum them up, then we get the 180 degrees. So by using the property of the cyclic quadrilateral, we can conclude that the angle BAD plus the angle BCD, this sum should be 180 degrees. Now we are given the angle BAD in the question is 96. So from this we can find the angle BCD. So here we have the angle BCD as the 180 minus 96. So if we solve this up, then we get the angle BCD as 84 degrees. So here we have got the angle BCD, that is this angle as 84 degrees. Now since this angle BCD is 84 degrees, so now we can find the angle BCE. Why? Because we know that the angle BCD and the angle BCE forms a linear pair, and this is a straight line here. So we can say that the angle BCD plus the angle BCE, this sum should also be equals to 180 degrees. Why? Because this is a linear pair. So from this we are going to find the measure of the angle BCE. So the angle BCE would be, here we have the 180 minus BCD. So here we have the 180 minus BCD, and the BCD is 84. So here we have 84, and if we solve this up, then we get the measure of the angle BCE as the 96 degrees. So here we have got this angle as 96 degrees. Now we are going to consider the quadrilateral BCEF. So in this BCEF we can see that the point B, C, E, F, all of these 4 points lie on the circumference of the circle, and hence we can conclude that the BCEF is also a cyclic quadrilateral. Now since BCEF is a cyclic quadrilateral, so we are again going to use the property of the cyclic quadrilateral that the sum of opposite angles is always 180 degrees. So here we have the angle BCE. So since this is a cyclic quadrilateral, we have the angle BCE plus the angle BFE. This sum should be 180 degrees. So from this we can find the measure of the angle BFE. So the angle BFE would be, here we have the 180 minus this angle BCE, and the BCE angle is 96 degrees. So here we have 180 minus 96, that is 84 degrees again. So we have got the measure of the angle BFE as 84 degrees. So this is 84 degrees. Now in the question they have asked us to find the angle BCD and BFE. So here we have got both of these angles. Now in the second part of the question they have asked us to prove that the AD is parallel to FE. Now for proving that these two sides are parallel, we are going to consider the sum of the angle A and the angle F. So here we have the sum of the angle A plus angle F as the 96 degrees plus the 84 degrees. So if we sum them up, then we get the 96 plus 84, that is 180 degrees. So we have got the sum of the adjacent angles of this quadrilateral as 180 degrees. Now we know that since the sum of the adjacent angles of a quadrilateral is 180 degrees, so that quadrilateral would be a parallelogram. So since sum of adjacent angles of quadrilateral is 180 degrees. So it only happens when the quadrilateral is a parallelogram. So from this we can conclude that the AFED is a parallelogram. So we have proved that AFED is a parallelogram. So we can say that the AD would be parallel to FE. So we have also got that the AD is parallel to FE. Why? Because these two are the sides of the parallelogram. So in the question they have also asked us to prove that AD is parallel to FE, and here we have done that. Now we are also given a second question. So in the second question they have given us that the ABCD is a parallelogram. Then a circle passes through the vertices A and B, and the circle meets the side BC at the point P and side AD at the point Q. Then in such a case we need to show that the quadrilateral PCDQ is also a cyclic quadrilateral. So let us first visualize this question by using a diagram. So let us first draw the quadrilateral ABCD, which is a parallelogram. So let us say that here we have drawn the parallelogram like this. So this is the parallelogram ABCD. So let us name it. So here we have the parallelogram ABCD, where this is the point A, this is the point B, this is C, and this is D. Now we are going to draw the circle which passes through the point A and B as given in the question, because in the question they have given us that the circle passes through the points A and B and it meets the BC side at the point P and the AD side at the point Q. So now we are going to draw the circle which passes through the points A and B. So here we have the circle which passes through the points A and B, and here it cuts the BC side at the point P and it cuts the AD side at the point Q, like this. Now what we need to do? In the question we need to show that the quadrilateral PCDQ is also a cyclic quadrilateral. So we need to prove this quadrilateral. So let me construct the PQ side here. So if we construct the PQ side, then it would look something like this. So this is the PQ side. Now we need to prove that this PQDC is also a cyclic quadrilateral. That is, the points P, Q, D and C, all of these 4 points also passes through the circle. So for doing this question we are going to name some angles. So let us name that this angle is angle 1, this is the angle 2, this is the angle 3, and this is the angle 4. Now since we know that the point ABPQ, all of these 4 points lie on a circle, so we can say that the ABPQ is a cyclic quadrilateral. So here we have the ABPQ as a cyclic quadrilateral. Now since this is a cyclic quadrilateral, so the sum of opposite angles of this quadrilateral should be 180 degrees. So here we have the angle 1 plus angle 2 is equals to 180 degrees, like this. So let us name this result as result 1. Now we can also see that the angle 2 and the angle 3, both of these angles form the linear pair, because the BPC is a straight line here. So since the angle 2 and angle 3 form the linear pair, so we can say that the angle 2 plus angle 3 should also be equals to 180 degrees. So let us name this result as result 2. Now if we assume that the angle 1 is equals to theta, then from this first equation we can find the value of the angle 2. So the angle 2 would be the 180 minus angle 1, and angle 1 is, we have assumed that as theta. So we have got the angle 2 as 180 minus theta. Now since angle 2 is 180 minus theta, so if we substitute this value here in this equation 2, so in place of angle 2 we write 180 minus theta, and here we have the plus angle 3 is equals to 180. So from this the 180 and 180 gets cancelled out, and we get the value of angle 3 as theta. So we have also got the angle 3 as theta. So we can conclude that the angle 1 and angle 3 are equal to theta. So here we have concluded that the angle 1 is equals to angle 3. Now here in the question we are given that the ABCD is a parallelogram. Since the ABCD is a parallelogram, so we know that the adjacent angles of the parallelogram sums up to 180 degrees. So according to this property we can say that the angle 1 plus the angle 4 would be equals to 180 degrees, because they are the adjacent angles of the parallelogram ABCD. So here we have the angle 1 plus angle 4 is equals to 180 degrees. Now from this equality we are going to find the value of angle 4. So from this equality we can find the value of angle 4 as 180 minus angle 1, and the angle 1 we had assumed theta in the beginning. So here we have theta like this. So the angle 4 is 180 minus theta. Now in the question they have asked us to prove that the PCDQ is a cyclic quadrilateral. So we know that in a cyclic quadrilateral the sum of the opposite angles of the cyclic quadrilateral is 180 degrees. So if we prove that the opposite angle sum, that is the angle 3 plus angle 4 is equals to 180 degrees, then it would also prove that the PCDQ is also a cyclic quadrilateral. So now we are going to prove that the angle 3 plus angle 4 is 180 degrees. So now we are going to find the value of the angle 3 plus angle 4. So angle 3 was equals to angle 1 as we have discussed here, and the angle 1 was theta. So here we have got the value of the angle 3 as theta. So the angle 3 is theta plus angle 4, and here we have calculated the value of the angle 4 as 180 minus theta. So here we substituted and we get the theta and minus theta getting cancelled out, and we get the angle 3 plus angle 4 is 180. So here we have got the angle 3 plus angle 4 is 180 degrees. So we have got the sum of this angle and this angle as 180 degrees, and we know that in a cyclic quadrilateral the sum of opposite angles is 180 degrees. So here we have got the sum of these two angles as 180 degrees, and hence we can say that the quadrilateral PCDQ is also cyclic. So here we have proved that the quadrilateral PCDQ is also a cyclic quadrilateral. So this is our solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.